The primary focus of this presentation is to analyze how secondary succession is taking place in Point Pleasant Park, located in the south end of Halifax. This is being examined by the change in the forest over a period of time by collecting data at 6 heavily impacted areas of Point Pleasant Park. Succession can be defined as a change in an ecological community after a disturbance such as a natural disaster. Secondary succession is described as an event that disrupts an environment that does not include the covering, removal, or creations of new substrates in the environment. Events can be fires, tornadoes, hurricanes, and other natural disasters. The origin of secondary succession being observed in Point Pleasant Park comes from the damage done during a hurricane in 2003 on September 29th. Hurricane Juan was a Category 2 hurricane which made landfall in a community called Prospect, located south from the city of Halifax, Nova Scotia. It had sustained winds up to 151 kilometers per hour and was deemed the worst storm since 1893. Point Pleasant was an even-aged old-growth forest, as it was a planted forest around the military base made by Edward Cornwallis, who had leveled most of the park in an effort to use it for resources, but instead overexerted old trees planted there. While the Mi'kmaq used the area as a summer fishing camp, their technology, aside from fire, would have little impact on the natural forest. Cornwallis introduced to the Halifax Peninsula 4,000 soldiers and settlers with an insatiable need for wood. They brought with them metal saws, metal axes, shovels, and pickaxes. They also introduced heather, other unknown flora, seeds, fauna, and most likely insects. The park's forest since then has experienced many trials, as the military slashed and burned the park in 1884 for military reasons. The trees also had not much success, as the overload of oil and dust coming from nearby roads prevented growth. Up to 70% of the trees have been removed or uprooted because of the shallow soil layer, leaving Point Pleasant Park essentially bare after Hurricane Juan. The data collected from Point Pleasant Park was the tree density as well as the size. The data allowed us to examine the changes in the forest over time and calculate the species richness, evenness, as well as the diversity and density, and how it has changed since Hurricane Juan in 2003. The primary focus of this presentation is
Methods, equipment, and procedure to study the ecological succession and biodiversity patterns at
The selection of specific
The forest has sustained a substantial amount of damage since Edward Cornwallis made landfall here in the 1800s. This resulted in soil contamination, dead trees, and the introduction of foreign plants as well as foreign organisms, with the steady increase of militarization and people immigrating to Canada through the ports. Based on the graphs provided to us based on data collection, the trees and diversity of the forest have experienced a steady increase since 2005. The total density and richness both have an even increased trend since 2005 while still retaining a small amount of lower numbers as it increases. I can predict that as the forest continues to grow, that the numbers should increase on the same trend if conditions remain the same and if no other events take place that could prove to be detrimental to the health of the forest.
red maple and red spruce are two of the dominant species in Point Pleasant Park. Over the past 2 decades, the density of red maple has consistently increased as shown by the positive regression slope. Comparative analysis shows a significant linear increase in the density of red maple from 2004 to 2023 with a slope coefficient of 2.5646. This trend is statistically significant with an R-square value of 0.1549, indicating that approximately 15.49% of the variation in red maple density over time can be explained by our linear model supported by the p-value that's less than 0.05. This increase is largely due to red maple's adaptability to varying soil conditions and its competitive advantage in recovering quickly from disturbances such as Hurricane Juan. Its ability to thrive in both shaded and open areas allows it to fill gaps created by the hurricane and other disturbances. As the forest ecosystem continues to evolve, we anticipate that red maple will play an increasingly dominant role in the climax community in Point Pleasant Park. Its fast growth rate and adaptability to diverse environmental conditions make it likely to become one of the predominant species and potentially leading to a forest structure that supports a mixed deciduous coniferous composition, where red maple could maintain its dominance or even increase due to ongoing environmental changes.
Discussion, ecological implications. The observed trends support this idea that with that there has been no significant change are gradually re-established in Point Pleasant Park. This is a process that started and 2023, where species it is assumed that any variation in red areas affected by this is due to natural fluctuations rather than a long-term increased trend of recovery or particularly will alternative hypothesis. This hypothesis suggests there has been a significant increase in red spruce density. This potentially indicated a recovery or adaptive reasons first growth pattern following a hurricane Juan. It highlights how 2003 parks Hurricane Juan caused substantial damage to the forest structure with red spruce playing a role in stabilizing the forest structure. Red spruce density, resilience, and adaptation. The increase suggests that red and adaptation have traits that make it resilient to the conditions. The graph created by the hurricane individual data points representing red space density measurements, or reduced competition annually from 2004 to 2023. Biodiversity line by tracking red spruce density over time, researchers can better understand biodiversity patterns and species interactions in the park, of the line, especially as a response to climate events indicated a gradual upward trend in red spruce density over the years. So in summary, The R squared, or the coefficient of determination, though modest, increased in density over the years following Hurricane Juan, reflecting an adaptation around 12.3% within the forest ecosystem. Variance in red spruce density is explained by the system line. While this doesn't indicate a very strong correlation, it does suggest a modest increase. Monitoring this pattern over a longer period could reveal by other ecological impacts of disturbances and the role of red spruce in forest recovery at Point Pleasant Red spruce density change.
An important metric in determining the health and stage of forest succession. And as we can see in species 5, the species richness in Point Pleasant Park has increased 368% from where it was in 2004 with our most recent data in 2024. It is typical of an early successional forest, especially when that forest is disturbed by a windstorm, because the windstorm allows for shade-intolerant pioneer species to have a chance at attaining sunlight and colonize the area. Once these pioneer species have established themselves, more species will also recolonize the area from adjacent subpopulations, and the species richness will only increase until reaching a later stage of succession. In this later stage, the nutrients in the forest will be in higher demand, and species more suited for competition will dominate the environment and push out the other species until the next disturbance. When we consider that before Hurricane Juan, Point Pleasant Park was dominated by red spruce, and that currently, according to our data, while red spruce is fairly abundant, red maple is similarly abundant, and so we can assume the forest is not quite at its climax community, and that species richness will continue to increase until it reaches that point. Based on the trends in our data and succession theory, we can predict that Point Pleasant Park is in a middle succession stage. This prediction is based on the comparison of the community makeup before and after Hurricane Juan. Before Hurricane Juan, the park was dominated by red spruce, and while the proportion of red spruce has increased since 2003, it has yet to reach the same level of dominance. The fact that it is an urban park certainly has an effect on the succession of Point Pleasant Park. One difference is the proportionally high abundance of exotic species found in urban forests. Horticultural practices are common in urban forests and often cause park designers and maintainers to plant exotic species to achieve a pleasing aesthetic, as opposed to planting native species. The effect of this on the succession of the forest is very complex, and while it can increase overall species richness, the exotic plants are less resistant to disease and create a much more sensitive habitat, as well as not being the best equipped to build foundational elements of the park, like soil and such. While both urban and non-urban forests face natural disturbances, urban forests also face a frequent rate of disturbances caused by anthropogenic activities. Despite being fairly small in extent, the frequency of these disturbances certainly can alter the forest's properties, often in difficult to predict ways. These activities, while they cannot realistically be eliminated, can be limited, and a couple ways this could be done would include fencing off particularly sensitive areas or narrowing the trails throughout Point Pleasant Park. A Western scientific analysis can be effective at taking apart systems like forests, investigating their mechanisms, and then suggesting ways in which we can manipulate these mechanisms to make the whole system work better. However, how can we do that if people don't care about Point Pleasant Park in the first place? The concept of two-eyed seeing encourages us to embrace the strengths of both a scientific perspective and an indigenous perspective. An indigenous approach to improving the regeneration of the forest could include making people respect Point Pleasant Park more, perhaps through guided tours or activities, in order to incentivize them to actively pursue Point Pleasant Park's regeneration. We would like to thank Allison Schmidt and Tegan Robinson for assisting us in lab with this presentation, and we would also like to thank the previous ecology students at Dalhousie for collecting the data that we used for this presentation.